for this next one. If I say f of x equals negative 2x plus 2 squared plus 3. Before I graph it, I'm going to already get a kind of a plan of attack. I'm already going to have an idea of what this graph looks like. How many different things are going to affect what this graph looks like? 4 things. I think of this negative as its own thing. The number here as its own thing. The number here as its own, and the number here. So let's go to the ones that we know pretty well. What does this tell me I'm going to do? Left 2, which means negative 2 is my x. What does this one tell me? So positive 3 is my y, yes? Okay, what does this tell me? Vertical stretch, which means if I pulled vertically on the ends, what would that do to a parabola? Make it skinnier or wider? Make it skinnier, so I'm going to pull it on those, right? So it's going to make, I know it's going to be a little skinnier than normal. And what does this negative tell me? It's going to be reflecting down, so it's going to be facing down. I have this picture in my mind. I also know that this is, where's the vertex going to start? In quadrant what? It's in quadrant 2, so when I draw this graph and I know it's facing down, I'm going to kind of focus in on quadrant 2, but really, I need to focus in quadrant 3 more, because I know that this is going to go here, negative 2, and positive 3, but what do I know about it? What do I know about that point? That's the max it's ever going to reach, so for my range, I know I don't have to go any higher on my y, because it's going to be from here on down. Yes? Now, what would be my next point that I'd plug in? I plug in negative 1. Negative 1 goes into right here. Yeah, you got to be able to do this in your head, right? Negative 1 plus 2. 1 squared. 1. 1 times a negative 2. 1 times a negative 2. Negative 2 plus 3. So negative 1, 1. Wait. How do we normally do this? From the vertex, we normally go over 1, up 1, right? That's the OG. If I'm talking about, remember, I'm always going back to the parent because it's the transformations come from the parent. So normally, the parent is over 1, up 1 every single time, yes? What did this one do? Over 1, down 2. Why does it make sense, though? Hey, it's a stretch by 2. It should be doubled. That's what that stretch does. Instead of moving only 1, it moved to 2. And also, what else? Negative. What did the negative do? Instead of moving it up, it made it move down. It's everything that I thought should have happened. Are you with me on this? What would be the next number I plug in? 0, which is also known as my what? Nope. It's not my origin because it's not 0, 0. If x is 0, what can you guarantee that point to be? So I'm going to find the y-intercept just by chance on this one, but I know it is the y-intercept. How do I know? Whenever my x is 0, that's my y-intercept every single time. So we plug in 0. 0 plus 2 is 2. 2 squared is 4. 4 times the negative 2 is negative 8. Negative 8 plus 3 is a, what kind of 5? So if you would put a 5, Ed, you said 5. Well, I heard 5. So let's pretend we accidentally made a mistake and we put a 5 in here. We would be going up to here, and what would we know? That's messed up, right? Because we have that number since I've been trying to get you going, wait, that doesn't make sense. That can't go up here. So I go back and I go, oh my gosh, I forgot the negative. All right? So then 1, 2, 3, 4, 5, right here. By the way, that's over 2 down 8. What is my OG normally? Over 2 up 4, right? Doesn't it make sense that it's over 2 and down 8 on this one? Because it's stretched by 2? You understanding? And then what do I do to finish this problem off? All I gotta do is mirror it, which would be over 1, down 2, over 2, down all the way to here. Do you notice how the y's are the same on this? And the y's are the same? I just went over this way, and then this way I went over. Do you get what I mean by that? How I mirror? And then draw your line or your point. That was terrible, but something like that. What is the axis symmetry? Good, don't just say -2. It's x equals -2. It's that line. Make sense? All right. The one that's kind of a pain in the butt. We talked a little bit about this, but I told you I was going to do it more when I got to this section. Can't hear you. Yeah. Yep, axis of symmetry. This one's a pain in the butt. In order for us to have a horizontal stretch, it has to be like 2 and then x, like that. Okay? So here's the problem. It's not written in that form. So we actually do not have a horizontal shift of -4. This is actually not moving it to the left -4. I know it looks like it, but it's not. Because of this 2 right here. Because of this guy right here. So let's go back to Algebra 1 for a minute. And maybe even before Algebra 1. But you're going to hear me say things all the time because I'm trying to bring it to your attention, because the more that you start to see math and the way that it works, the more it becomes easier to you. So what I mean by that is, in Algebra 1, maybe even before that, what were you taught to do with this 3? Which, by the way, you don't have to do all the time. It's just something you can do if it helps you solve your equation. So sometimes we do this, sometimes we don't. And you said distribute it, right? So you said this times this, so it turns into 3x plus 6, right? And I don't know if it's teachers don't do a good enough job of explaining this, or if it's students. I don't know where who to lay the blame on. I don't really care. What we need to know is, if we can go this way, whenever I say something is equal in math, if I can say, you can take this and rewrite it as this, you can take this and rewrite it as that. It's like undistributing. It's reverse. We reverse all the time in math. Yeah, we did a little bit. So it's just rewriting and changing the way it looks. Like here's one thing that I just did in my other class, and it's funny the answers that you get, because you don't really think of it like that. And that's what I'm trying to change. What do you do to this? You simplify it, and it becomes what? How do you change that? How do you change that to that? Here's another common mistake that people say all the time. How did you change 10/12 to become 5/6? Yeah, it's perfect. Yeah, but she said you divide by 2. No. See, if I divide by 2, and it's these little things that once you make the comprehension and start understanding, that it, again, starts unlocking it. If I divide by 2, that's what you told me to do, correct? That's what you said. Then I would keep change flip. So that's not what you meant. No. Oh, what number do you really divide by when you divide by 2 over 2? When you divide any number by 1, what does it not do? it doesn't change the value of the number. Just like when you multiply by the number 1, it doesn't change the value of it. All you're doing is changing the way it looks. So what you did is you should say, I'm dividing by 2 over 2. Because when you divide by the number 1, this doesn't change the value of that number, it just changes the way it looks. Now, I'll go to kids and go, do you ever undo that? And the first grade goes, no. Can you add those fractions together? What did you do to add them together? You have to unsimplify the fraction. You have to go, hey, I'm going to times the bottom by 2, but whatever I do to the bottom, I have to times the top by the same number. Why? You're multiplying by the number 1, and when you multiply by the number 1, you're not changing the value of that number, you're just changing the way that it looks. And now we just unsimplified that number so that these guys could have the same denominator, and we can say, hey, that's 11/12. Right? This is what math is. It's constant, changing in things. This is, I don't like this form, it's not good for me here, I'm going to change the way it looks. That's all I do all day long. I'm telling you, if I could do it to people, I could make a lot of money. But I can do it to numbers, so I make no money. Right? That's all we do. I'd be called a plastic surgeon, by the way, if I did the other one. Cuckoo rich, right? No. No, God, I already paid that crap off. All right, so here's what we're going to do. We're going to undistribute this one. In order for us to see actually the horizontal shift, we cannot have it with this 2 on that X. So I'm going to do a big parenthesis here. And then how do I undo that? Let's go over here. Let's do one like this, and then we'll apply it to that one. What do these both have in common? So I go 5, and I pull the 5 out. And then I put a parenthesis here, and I go, okay, I have to have 5 times something get me back to here. Then I fill that in with an X. Now I need 5 times something get me back to a positive 10, and that's why I filled it with positive 2. Right? Same kind of thing over here. So what do these both have in common? What do they both have in common? 2. And then times the quantity is the way you say this. 2 times the quantity, X plus 2. And you can have parentheses inside parentheses, right? This now tells me it moves left 2. Do you see the difference between this one?
So every time you see it like that, you gotta switch it.
Why does it make such a difference?
Because there's a multiplier in there. That 2 is pumping this shift up more than it needed to be. Right here, you see how there's no. So that's just going to be a shift of 2.
Oh.
This right here is causing the issue. So that's why I got to get it out of there. Because it's a horizontal compression that's happening. So now I can say I have a horizontal compression. Remember, it's the opposite of what I think. Bigger than 1, I would normally say it's a stretch, but it's inside, so it's opposite of what I think. So it's a compression and a shift of 2 left. Yes or no? All right, last thing we need to go over. What time do we get out of here? Oh, we're good. Last thing we really need to go over, and then I'm going to give you one to practice on your own, is if I said I have 2, -3 is my vertex. This is one you need to really watch. And I say your y-intercept is -4, whatever. I don't care if it works out nice and pretty. We need to start seeing some ugly numbers. Everything is worked out to be positive and whole numbers, or we need to get rid of that. We need to start getting some fractions up in here. Yeah, I know. And I ask you to give me the equation of that. Okay, for vertex form, which is what we're dealing with right now. We dealt with vertex, we're doing vertex form, that's what this is called. I'm going to write it as y. It really could be written as f of x. Does everybody understand that? Don't freak out. This is the form you've seen, okay? This is the movement left or right, yes. This is the movement up or down. Whenever we did that, what did I always find first when I looked at the left and right movement and the up and down movement? What did I write? The vertex, yes? What did I give you over here? So we're going backwards like I talked about, right? So normally I give you the formula, you give me the vertex. In this case, I gave you the vertex, you're going to give me the formula. So the first thing we can find is we can find the h and the k really easily. They gave it to me right here. Be careful. Y equals a x. Remember, it's always the opposite, right? I want this thing to move it right too. I would think that I'd put a plus 2 in there, correct? Like normal, but I know it's the opposite, so I put a minus 2. You with me? And then what at the end? Minus, that's a 3. That, remember, it comes from the vertex. Don't worry about this yet, the y-intercept. I'll explain that in just a minute. Now, in order to have the formula, I need 3 things plugged in. I need my A, I need my H, and I need my K. Where did the H and the K come from? The vertex. Does everybody understand those two? The pain in the butt one, a little bit, is the A. It's a pain in the A. And it's just... You with me? Okay. I need you to see this as just not the y-intercept. I need you to think of it as the point. What is the point when I have that as my y-intercept? Good. 0, -4. Now we have to go back for a second to the last chapter. Remember when we were doing subsystems of equations? I pointed out something to you. I said, hey, when we're trying to solve for a variable, why was it a pain in the butt when we were doing systems? How many variables were there? Sometimes 3, sometimes 2. What did we have to get? We did it with substitution or elimination, but what was the goal of that? We needed to say, hey, I don't care if you substitute and eliminate, but I need to get it to where it's just one variable. You with me on this? All right, look at this equation right here. How many variables are there right now? 3. Y, then an A, then an X, yes? This ordered pair, since I told you it's on this equation, it works. This ordered pair, remember I told you this is an answer, and there's multiple answers to a solution, right? This is one of them that if you plugged in this X and this Y, it would make this equation true, correct? What did I say this is? An X, and what did I say this is? If I plug those in over here, how many variables would I then have? And the only variable would be the, and I could use my algebra skills to work backwards and solve for my A, and then I would have my A, my H, and my K. I've got my formula. Are you following me? So what would I plug in for Y? -4 equals, nope, A times the quantity, 0 -2 squared minus 3. Now I'm going to do this as much as I can until I run into a problem. Then I'm going to work backwards. Here's what I mean by that. Can I do 0 -2? And that's what? Can I then take -2 and square it? Which is what? Can I then take that and multiply it by A? Can I actually get a number though? So there's where I ran into a problem. What I mean by I ran into a problem is I can no longer solve this forwards. No, what's positive 4? That's from over on the other side. This is the 4 right there. Now I have to start working backwards to get the a by itself, right? So I would add 3, and I get -1 equals 4a. Yes? Divide by 4, divide by 4. A equals a -1/4. So then I'm going to change the y to f of x. Remember, it's the same thing. And what would be my final formula? -1/4, parentheses, x minus 2 squared minus 3. There would be my equation for that.
That'll get easier, right?
What do you mean? All you need in order to have the equation in vertex form is you need an A, an H, and a K. Where did the H and the K come from? From the vertex. Grab them, plug them in. The pain in the butt was A. I use this point to plug in X and Y so that A is my only variable, and then I use my algebra skills, which I'm not trying to be mean. This shouldn't be hard. That should be something that you're going, that's algebra 1. I know how to combine like terms, move crap around, get A by itself. If you look at this, the majority of this problem, what is that all? That's all algebra 1. The only algebra 2 part is understanding that how to get your A and your H and your K. You probably did start it off in algebra 1. Does that make sense though? Questions on that? Does it always have to be the y-intercept? What if I just gave you another random point? I say that like -1, 3 is your vertex, and 4, 7 is another point on there. So this is what are these going to be referred to as? H and K. This is your H, this is your K, yes? Then you're going to use this point to plug in to find your A. And boom, you got that's the overall how I would do this problem. Now doing it, that's where algebra 1 comes in. Combining like terms, all that stuff. You have homework on this? Other than that, we good?
We got homework tonight.
Oh yeah.